Tonight, I'm very excited to have here again Dr. Chris Magryta, a good friend, a member of the Center's Advisory Board, and he joined Salisbury Pediatrics in 1999. He has a special interest in pediatric allergies, asthma, autism, and immunology. He studied integrative medicine with Dr. Andrew Weil at the University of Arizona School of Medicine. In addition to general pediatric care, Dr. Magryta provides specialized care in prevention, nutrition, and combines alternative medicine with traditional medicine. So we're very excited to hear from you tonight.
Thanks, John. Appreciate everyone turning out. So, first question I'd like to ask, how many people in the room know or have a family member with an autoimmune disease? Raise your hands. So a large percentage, more than half. So that's part of the reason I think this talk is pretty apropos, because unfortunately we're starting to see a humongous rise in the volume of disease. And that rise is not by accident. And I'm going to try and teach you why that's the case tonight. This was a daunting task for me. I spent the better part of the last 3 months figuring out how to put this talk into an hour. This is probably an entire semester course condensed into 1 hour, and I hope I get it across, so I'm going to do my best. Up? Is that better? How about that? Can you hear me well? All right. So I'm going to walk over here because I prefer to be moving when I talk. So this is Topsail Island. I start every talk with a picture. I used to use Ansel Adams, and recently with the advent of the iPhone X, the pictures are unbelievable. So this is just something I took with my phone in Topsail Island. I absolutely love it. It just shows the beauty of our state. So autoimmunity, where did we go wrong? I submit to you that this is a Center for the Environment. So we're going to talk predominantly about the environment and why our environment is unfortunately becoming toxic to us. I'm going to just do my standard acknowledgments. You can quickly look them over, but these are some of the best teachers that I've had over the past few years, and recently Dr. Sam Yannick in Chapel Hill has been unbelievably instrumental in helping me understand immunology to the degree that I never have in the past. A baby fills a place in your heart that you never knew was empty. This is truly how I see the world. I went into pediatrics because it's absolutely amazing to watch a child go from this tiny little creature into a teenager. I'm having my first round of teenagers graduating high school, and now I'm having my first round of children now having their own baby. So it's pretty amazing to go through this life. Autoimmunity history. So what is autoimmunity, right? Back in 1904, German immunologist Paul Ehrlich was looking at this disease, and he called it horo-autotoxicus. Essentially a toxic event, auto usually meaning self or going after you. And he was the first one to really understand what autoimmunity was. Subsequently, it's been identified as an autoimmune attack or an immune system going after you instead of going after the pathogens that it's meant to do. It's involved in a break in tolerance, and we're going to go through that a little bit more. The barriers that we have to protect us from the outside world. Predominantly, you look at your body and you think your skin is the number one barrier. But I'll show you a little later that that's actually a really small barrier compared to some other ones that we have. They're more critical. There's over 100 currently identified autoimmune diseases. Last time I checked, it's over 144 and counting by the year as we learn them, identify them, find a biomarker, and then the person who was previously told they are crazy now has a disease, right? And this is something people can understand. Celiac disease used to be a disorder where you were told there's nothing wrong with you, you're fine, and then all of a sudden we found an antibody against the gluten protein, and now we have a whole disease. And this is something you'll see in medicine over and over again. The absence of the disease biomarker does not mean absence of disease. Just like if you didn't see a black swan, doesn't mean it doesn't exist. Here's some of them, right? You can recognize many of them on there. This is only a small portion of them. I couldn't get them all on the slide, so I showed you what I could. Rising incidence of autoimmune disease. Okay, so you see 1950 to 2000. This is a scary graph. You can see the incline is something like we've never seen. So what would that be due to? You have asthma, type 2 diabetes, Crohn's, celiac, multiple sclerosis. Autism. Insane. Last check, autism is 1 in 44. This directly affects me because every day we see patients that are becoming autistic. And this is a huge societal problem. Why? What's going on? What's the big issue? So hygiene hypothesis was the first theory that came out. A gentleman by the name of Strachan looked at it and first said, okay, this has to be related to our exposure to microbes, our exposure to dust, our exposure to different normal environmental bacteria, let's say, or pathogens. He was then followed up by a guy by the name of Jean-Francois Bach. And they went and looked around the world and said, okay, where are these autoimmune diseases? And what else is going on in there? And they found a correlation. If you can see on top, you have tuberculosis and hepatitis A. The yellow is where you're seeing, the data is not provided, but all around there you see in the southern parts of the country, you see a lot of these disorders of infection. Then you look over here and it flip-flops, right? You see, MS is on top, insulin-dependent diabetes is second, then you have TB and Hep A. So you see TB and Hep A all in the sub-equatorial areas, and then you see the disease that we talk about as autoimmune disease is predominantly in the other side. So the initial thought was, okay, we have a problem here. We have infections occurring. We have no disease of the immune system attack. We have no infections occurring. We have disease attack. So this was the first look at this problem and said, okay, what's really going on? So they followed it a little bit further, and then they said, okay, well, what else is going on? And they noticed that parasites. Here's all the parasites, where we see tons of parasites. And look at the autoimmune diseases. So the theory is now becoming likely it's heavily related to all kinds of pathogens, parasites being one. This was one of the landmark studies. This is specifically looking at asthma and allergies, innate immunity and asthma risk in Amish and Hutterite farm children. The reason they chose this population is because they're genocentric. They're very similar gene pools. So you don't have this variable of multiple different genes being involved in this to cloudy or muddy the study. So they looked at it and said, okay, what happens with these humans that live in these enclaves? The Amish tend to live in micro farms. So the father, the mother, and the children all live on the same farm. The children are exposed to the animals. The Hutterite farms were more mechanized. So the children all lived peripherally. The men went inside to the farm and worked on the farm on the inside. So then they went and said, okay, well, what's going on here? They studied the dust of these homes. They found that the dust of the children that were Amish had lots and lots of endotoxin in it. Endotoxin is basically bacterial cell wall debris, different parts of pathogens. And then the Hutterite homes didn't have as much. Then they went and looked at the statistics of how much disease these children had. And they found that the Amish children had almost no asthma and allergies, but the Hutterite children had roughly 30% more. Okay, so they said, okay, there's something going on here. Then they said, okay, let's take a proof of concept. We have a mouse model for asthma. They took the mouse model at birth and gave the mouse model exposure to the dust. So these babies are just born, they're exposed to the Hutterite dust, they develop asthma. They're exposed to the Amish dust, no asthma. That was landmark, because now you know that it's not genes turning on the problem. There's an environmental signal turning on the disease or turning off the disease. So this was the beginning of our true understanding that there's more to this story than the genes that you have are the answer. So we're going to talk a little bit more about this, but human microbiomes are likely a big player. You've heard about the microbiome now. This is becoming the big hot topic in medicine. We're starting to know that we have microbes all over our body, in our gut, in our lungs, everywhere, and they provide us either benefit, not much, or curse. And it depends on what we have which dictates that. They looked at this and said, okay, humans with autoimmune diseases are observed to have dysbiosis. That means in their gut they have dysfunctional bacteria compared to healthy people. Then they went and looked and said, okay, what about non-obese diabetic mice? Will they develop autoimmune disease if they're bred in a germ-free environment? The answer was yes. So the germs were actually protecting against disease. Then they said, give these same mice exposure to Mycobacterium, Coxsackie virus, Salmonella, and parasites, and see if they develop IDDM. They did not. So yet again, proof of concept that the exposure to the microbes is making a big difference. They looked at another study, Karelia versus the Finnish. Karelia is a part of Russia, Finnish people clearly from Finland, and they looked at their rates of insulin-dependent diabetes mellitus. And they found that these are very similar genocentric people again, but just the border, difference in exposure to microbes and cleanliness, the Finnish people had much higher autoimmune risk than the Karelians. And they said, okay, this is interesting, because at first there was discussion about vitamin D being a major player. No difference in vitamin D between these two groups, coming back yet again that the microbes are the bigger player. East Germany versus West Germany, right next door to each other. Before the reunification, everyone thought East Germany would have much more disease because it was a much more dirty, polluted environment, right? And they said, okay, the pollution of the environment has to be the mitigating factor of developing disease. When they looked at it, the answer was not so. The West Germans had much more disease because of, now we believe, hygiene hypothesis. So we need a trigger. Just like everything we know in medicine, cancer, there's a trigger. Something has to turn on our problem. What is that trigger? So I'm going to submit to you that the trigger is dysfunctional tolerance, host genetics, and microbiomes all have to be messed up in order for this to go wrong. Then what's the next trigger, right? So you have to have an antecedent, the dysbiosis, the lack of exposure to microbes, the tolerance mechanism is broken, and then something has to turn it on. So what is it, right? Here's the question. What about air pollution? You guys have been to talks here before, and we've talked about air pollution. PM 2.5, microscopic size. Is air pollution a big problem? Let's look at a disaster. Everybody knows this one, right? This was an amazing experiment that nobody wanted to happen, but happened, okay? These planes flew into these buildings, exploded them. The buildings crashed to the ground, and everything that was used to make these buildings all of a sudden ended up in the air. Anybody who was around these buildings at the time was exposed to this product, whatever it was. Metal, silica, asbestos, whatever it was, right? So they studied, looked at this. Mayo Clinic proceedings. Post-September 11th, 2001, incidents of systemic autoimmune diseases in World Trade Center exposed firefighters and emergency medical service workers. Okay, first responders. They did a service, they went in. Unknown to them what their risks were going to be. So they looked at it. Prolonged work exposure conferred a 13% increased risk for each month at the World Trade Center site compared with risk in those who worked only 1 month. The first ones to arrive had an independent risk. Okay, this is straight epidemiology. We're not proving causation yet. We're just proving association. They were there, they showed up, they got exposed, they got sick. So what else did they show? This is what was in there. They found amalgams of pulverized cement, glass fibers, silica, asbestos, lead, polycyclic aromatic hydrocarbons, polychlorinated biphenyls, polychlorinated furans, dioxins. All of this stuff was in the air. So let's look at an autoimmune disease. So we have a belief that there's a hygiene hypothesis that's part of this. We think now that chemicals may be playing a part. I'm going to try and prove to you how this goes from point A to point B. This is the hard part that I spent the last 3 months trying to do without making it too scientific. So, rheumatoid arthritis. Lots of people suffer RA. Autoantibodies found. You develop joint symptoms. Your joints start to swell. They start to hurt. You can no longer use your hands unless you get on the medicine. A lot of times we put them on DMARDs, these drugs that specifically target the chemical that's inducing the inflammation. But why did this happen? Is the immune system really attacking you? Right? This was the question, because when I was in medical school, that was what we said. The immune system is attacking your cells. Never made sense to me. Didn't think about it much back then, but a lot of these things never made sense. Time has proven these things out. So what's really going on? And I'm going to show you that what's really happening is they're forming new antigens. For those who don't know what an antigen is, it's a protein structure. Right? It's what our immune system goes after when it doesn't like something. So if virus enters your body, you'll have a protein structure. The immune system will recognize the antigen, right? This is part of the protein structure that's there that it wants to learn, memorize, develop antibodies to, and later kill. This is how we survive infections. So let me give you an example. How do we handle a parasite? So the microbe up in the upper left corner there is the parasite. He comes in, little bits of his protein get released, gobbled up. That little cell there called antigen presenting cell sticks a little hand of the protein up on a little platter and says, hey, come by and taste me. I need you to understand what this is. So it comes by and tastes it, sends out these little white blood cells called T helper cells, and then they clonally expand into different types of cells to learn memory. The reason we do this is so that we can memorize this parasite for the future, so if this parasite shows up again, we can kill it more rapidly. Everybody knows you get chickenpox the first time you get really sick. That first time, you haven't developed antibodies yet. So during the process of getting sick, you develop antibodies. And then the second time you see anything happens of this virus, you kill it right away because you have the antibodies ready to go. So in the parasite's case, we learn what these parasites are, and then eventually we release these certain types of cells to kill it. That's normal. Let's look at RA. Anticyclic citrullonated peptide antibody for rheumatoid arthritis. This is what we test. If we draw your blood, you show up in the hospital or the doctor's office, we test you for anti-CCP. When I ask the medical students, what's anti-CCP? What do you think they say? Oh, it's an antibody for RA. Well, what is it? Well, I don't know. It's an antibody for RA. What is it? I have no idea what it is. So I'm going to tell you what it is. So let's talk about 96% specific for RA. That's unbelievable. In medicine, a 96% specific test is perfect. Elevated titers detected greater than 10 years before the onset of disease. So you are 10 years developing signs of autoimmunity before overt disease. That's a huge thing to know. Sensitivity increases from 50 to 75% of the course of disease, and then it's likely involved in pathogenesis. It looks like it is. And these antigens are highly expressed in the joints. So we think we have the prototypical reason why you're getting sick. You have these antibodies, your body's attacking self. The part of the self that it's attacking is your joint. So you develop disease. Okay, here's the joint. So you see this part of the joint right here. Healthy's on the left side, RA's on the right side closer to me. What's going on here, fascinatingly enough, is this peptide right here called arginine. It's an amino acid in that protein gets shifted to a citrulline. That's all that happens. But something has to cause that to happen, and I'm going to show you what does. By the time that happens, all of a sudden this neoantigen, this new protein structure that the body doesn't understand, now becomes something the body thinks is not supposed to be there. So we're not actually attacking you. We're attacking a morphed version of you. But what caused it to morph? That's the question. So here's my chicken scratch. This is what I do in my office at night. So you see air pollution, PM 2.5, via the lungs, that air pollution gets in, it causes a citrullination of these proteins. So air pollution has been directly shown to be able to induce citrullination. The anti-CCPs formed, you have immune activation. Now that you have immune activation, what are the other things that need to be in place for this to go south? Well, air pollution also makes vitamin D harder to get. Well, vitamin D happens to be very important in suppressing immune system gone awry. It's the military police for the immune systems, Army, Air Force, Navy, and Marines. If the Army and the Air Force are not busy, what do? They go to bars, they party, and they beat up the place, right? So you need the MPs to throw them in the brig. Vitamin D helps develop those cells that throw the guys in the brig. Okay, it's very important. But we're blocking that. Okay? And then via the lungs, you can also see up there something else called reactive oxygen species. ROSs are very good. Your body makes them all the time, and it uses them specifically to kill pathogens. But if you make too many of them, all of a sudden they can become counterproductive. This is the genesis of all disease now we're learning is inflammation. Inflammation is going to be a key word you hear from now on until the dawn of time. Any disease you show me, I'll show you inflammation is probably the main driver behind all of it. Alzheimer's, diabetes, inflammation of joints. It's all the same, just what's the antecedent. So you can see here, there's just some fancy stuff here, but mental stress, abnormal microbiome, standard American diet, all these things play into increasing inflammatory side, the big I, right? That's the word I'm going to use all the time, inflammation. Inflammation then comes down with the immune attack, and all of a sudden you start to damage that joint. Fascinatingly enough, if you keep damaging that joint, you'll make more antigens, more new antigens. You make more antibodies, and eventually you can't slow the process down because you made all these proteins to kill structures inside your body that shouldn't be there. So they looked at it and said, okay, does oxidative modification of proteins, is it there? And they've shown, yes, it is. Lupus, RA, all these are diseases we found. So we know that that last slide is true. So then, environmental triggers. Well, cadmium, cigarette smoke, turns out to be one of the best ways to turn on citrulliнаting of proteins. So if you're a smoker, you have a very high risk of developing rheumatoid arthritis, right? And it shows the picture, right? There you go. You citrullinate the proteins. The citrulinated proteins get overreactive. All of a sudden, they start to attack your joint. You have disease. But you have to have other things in place, too, right? So you see there that little DNA Watson-Crick helix. If you have the predisposition for the right gene pool, then that risk is there. Everybody knows the guy who smoked, drank, ate bacon, eggs every day, and he lived to 95. He has perfect genes. They exist. But for the vast majority of us, that's not the case. If you have these markers right here, HLA-B54, HLA-DQ1B, HLA-B40, these are human leukocyte antigens. If you have those risk factors, they set you up for potential problems. Okay, so now I'm showing you it's not just the microbiome being messed up. It's not just not being exposed to enough toxins. It's not just being exposed to the cigarette smoke. You also have to have the genes. Okay? So the story gets even more complex. But what we do show is that there's my big friend, inflammation. As soon as you have antecedent triggers for inflammation and you develop an antibody, you have gasoline for a major fire, and now you have a problem that we call rheumatoid arthritis. Okay, here's some study data. Cigarette smoking and autoimmune disease. What can we learn from the epidemiology? If you are a cigarette smoker, you have a 4.4 times increased risk of developing RA. Smoking increases seropositive RA 2.4 times in women. Men have a twice-fold risk. So must mean something to do with men's genetics. Smoking intensity and duration both greatly increase risk, and this is very well known in toxicity. Time and duration is hugely involved in whether you develop disease or not. Increased risk remains for 20 years after quitting. Ooh, that's a bit scary. So what did they show? When we look at air pollution, going back to the earlier slide, particulate matter present in air pollution can induce oxidative stress, cell death, both by apoptosis and necrosis of human cells, leading to aggravation of chronic inflammation, tissue-damaging reaction observed in autoimmune diseases. Fancy way of saying air pollution, cigarettes, all of these toxins turn on inflammation, and they also put us at risk. So that's a big piece of the puzzle. Here's another study. Industrial air emissions and proximity to major industrial emitters are associated with anti-citrulline protein antibodies. So if you live near a highway, if you live near a chemical factory, if you live near something that's putting out chemicals into the air, you are going to be at a higher risk for developing citrullinated proteins. Right? Citrullinated proteins are not just related to RA. That's just the one that we know a lot about. So now we're getting a picture of, we have antecedent triggers, we have toxin association, we have inflammatory mediators, and then we end up with overt disease. Smoking and silica exposure are linked to RA and systemic lupus. I just read an article yesterday. It happened to come at the perfect time. They have these new granite countertops called faux granite. Anyone ever see the faux granite in Lowe's? Right? Instead of granite now, we use faux granite because it looks the same, but it's much cheaper. Well, in the process of making faux granite, they use a lot of chemicals that aren't very good, one of which is silica. Right? Silica is something natural from the earth, but it's actually toxic in high dose. They're now showing multiple studies showing how many of these guys that cut with machines, cut the faux granite, how many of them are dying of lung disease. Right? They first get fibrosis from all the silica getting in the lungs. The immune system tackles it, swallows the silica, develops inflammation, develops autoantibodies. If you don't die of fibrosis, you're going to die of autoimmune disease. This was just another one I threw in because I thought it was interesting. Endocrine disruptors, because we talked about BPA in this room before. Right? BPA depletes glutathione, which is the major chemical in the body that clears other xenobiotics, foreign agents, in the white blood cells, and then it shifts you towards Th2 polarization. That's just a fancy way for saying it shifts your immune system towards fighting parasites. Problem is when you're not fighting parasites, that Th2 polarization causes allergies, asthma, eczema, all the things that we see, that you see everybody sneezing all the time. BPA, boom. So let's look at the inflammatory process, because this is key. This eye, it doesn't matter with autoimmune disease. The eye is in everything. Cancer, right? Diabetes, non-autoimmune diabetes, it's everywhere. So what's the inflammation process? The environment, antecedent triggers, allergens, chemicals, infections, trauma, stress. All of these things can start the inflammatory process. How many people know somebody gets divorced and within a month or two of getting divorced they get sick? Right? Happens all the time. What is that? Mental stress. Mental stress is damaging, right? But so is trauma. We can show you data over and over again that people get hit in the head in a football game, slowly end up developing dementia. What is that? That's inflammation. You know, they learn this now. You need to have certain genes. Right? If you have perfect genes, none of it matters. Most of us don't have perfect genes. Diet, nutrition, macro, micro, phytonutrient makeup. This is going to be key. We'll talk a little bit more about that later. Brad Wright has brought these wonderful anti-inflammatory foods for us to understand. Function. The immune system then promotes inflammation that should stop. The military police aren't doing their job. We don't have a way to turn off the spigot of gasoline. Okay? And then chronicity. This keeps going over and over again. It cycles upon itself. And then we develop more and more disease. We develop more and more disease. And eventually we die hooked up to tubes miserably. And that's not what any of us wants. I want compressed mortality. I want to live, and then just drop dead. Don't care how. Just drop dead. So what causes a reaction in the body? Okay? So we know chemicals, heavy metals, pesticides, cigarettes cause a reaction. Everyone knows this, the nursery rhyme with Alice in Wonderland, the Mad Hatter. Right? The Mad Hatter went mad because he was using mercury to felt the hats. It was used in the felting process. He absorbed the mercury through his skin, or she, whoever made it, and then eventually it all got to the brain, and then it caused neurologic damage, and they went crazy, and then eventually they die. Right? So we know these things occur. Excessive sugar. This is a monster problem right now. Sugar causes glycation reactions, causes all of these problems in the body that is hugely pro-inflammatory. Fatty acids that are oxidized. This is your major fryer. Every time you go and eat a French fry out of a fryer that's been sitting there for a year, there are tons and tons of chemicals in that fat that's been oxidized. And these chemicals then get in your body and cause damage. Hypoxia, low oxygen. Right? For some reason, if you're sleep apneic and you don't get enough oxygen while you're sleeping, you're just putting your body into inflammatory states. Pathogens, right? So we know infections do this to us. Trauma of all types, plant and animal proteins, can be, interestingly enough, traumatic to us. They can cause inflammation. Sometimes good, sometimes not. So let's look at it as an algorithm. We have inducers, molecular triggers. Okay, these are environmental things of any type. We have sensors in our body to sense these things, are they good or bad. We have little things called toll-like receptors that all their job is to recognize patterns of proteins. They sit on cells all over our body, and if a protein comes by that looks like strep, it immediately grabs a piece of it, sends a signal down to the white blood cell and says, okay, strep's here, kill them. Okay? Then we have endogenous mediators. We have parts of the immune system there that's ready to go to town right away, even without antibodies being formed. Fish oil, you hear everybody talking about fish oil. Fish oil is actually a precursor to these some endogenous mediators that help resolve inflammation. Then the inflammatory response eventually is called itis. Now this is great if I kick you in the shin. If I walk up to you and kick you in the shin and you swell up, the itis is important to resolve that injury. It comes in, cleans up all the dysfunctional broken cells so you can build new ones and life is great. But if the itis goes uncontrolled, we have problems. So let's look at a picture of the whole story because we're about to go into the barriers. So we have genetic predisposition, we have environmental exposure, we have barriers, we have this gastrointestinal system with lungs and everything, then we have this inflammatory response, we either have homeostasis, which means we're doing it right, we have no disease, or we have dysregulation and we have disease. So now we're going to talk about what happens. So here's tolerance development. I'm in the process of finishing a book called The First 2,000 Days for Mom and Baby, and it's a story of how we as Americans or people in the world should be thinking about what does the vessel need to look like to produce the healthiest child. It's a very difficult topic to have as a man, right, with mothers and women, because there's a lot of guilt around pregnancy. And so I go at this story very clearly that this is purely scientific without guilt, and I don't believe in looking backwards. I only believe in looking forwards. So we talk a lot about this in clinic, like what can you do as a mother to be the best version for your child? And this is how it all looks. So we know the genome is there, right? Then the big question is, what's going on in the body barrier permeability? Fascinating enough. So I'm going to tell you a story about a microbiome, right? We have this gut microbiome, which has as many cells of bacteria as we have human cells in our entire body. It's a fascinating reality. It talks to us all the time, through our vagus nerve to the brain, through many other ways. At first trimester of pregnancy, a mother's gut bugs is whatever she's been eating, doing, antibiotic exposure, all these other things up until that point. From that first day of pregnancy until the third trimester is ended, mom's gut microbes shift and become fat storage types. So those microbes go and learn on their own, we have no idea what the signal is, to help mom store as much calories as possible. Right? This makes complete sense genetically. Think about a time long ago when you didn't have access to food all the time. Right? So all of a sudden you had food, your body would want to store all of that to keep the baby alive and then to make sure there's enough fat to make breast milk. This is normal. The problem is we don't have feast and famine anymore. We have feast, feast, feast. So now mom's microbiome that shifts to storing calories started out already dysfunctional. But the microbes don't know that, so they keep going. So they keep storing. So now we have a problem of pregnant mothers having microbiomes at the end of their third trimester, which is completely dysfunctional because the microbes haven't gotten the message that the storage capacity was already great. We're fine. We don't need any more. So we're learning now that this tolerance mechanism isn't working out right. These kids are being born with the immune system completely overreactive already. So your microbiomes, right? Here's your skin. Here's your lungs. Here's your GI tract. Your environmental exposure is mostly through your gut, secondary through your lungs, and very little through your skin. So if you think about your outside world exposure, what do you do every day? Eat 3 times a day or more. What do you do all the time? You breathe. All these routes of entry are how possible damage can occur. Your lung and your gut have defense mechanisms on purpose set up to handle anything that comes in. We have mucus barriers. We have little fingers that beat called cilia to push things back out. We have antimicrobial peptides. We have actually proteins there ready to kill bugs when they enter. We have antibodies and we have antioxidant chemicals that we get from plants, believe it or not, that help us deal with anything that enters our body that could be a problem. So this is now the new theory. 20 years ago, leaky gut was considered stupidity. Now it is the cutting edge answer to what's going wrong. In a normal situation, you have an intact barrier. That's how everything goes. Food comes through, you breathe, anything that comes in, your intact barrier recognizes it, tastes whatever it is, says, okay, you're good or you're bad, sends a signal to the immune system, this guy's bad, kill him, this guy's good, this is peanut, don't worry about him. Life's nice. You have a perfect child. Now let's say you have a dysfunctional barrier. What the reason is, there's myriad, right? We talked about many. One of them could be an abnormal maternal gut microbiome. Another one could be exposure to antibiotics right at birth. There's many different things that could do this, but something caused the leaky barrier, lungs, gut, somewhere. Then all of a sudden that protein now slips through, and that protein now is in an area that is normally conserved and protected. So imagine you're the White House, and somebody happened to get through that fence. What's going to happen to that person? They're going to be caught and rounded up really quickly. Well, 70% of your immune system sits right below that barrier. 70% sits below your gut barrier. Why would that be? Because that's where you get the most exposure to the outside world. Okay, so if your gut's not working right, in theory, you're going to have a really hyperreactive immune system. So in central tolerance, you have this system where your immune system recognizes a protein. It says, hey, you're good. I'm not worried about you. I'm going to teach my immune system that you're not a problem, and it sends a signal to the rest of those white blood cells. Don't react to this. That's called tolerance development. This happens in every single baby. If you've ever seen a baby at 6 months of age, what do? They taste everything, right? That's tolerance. They're learning right from wrong. But that's not working right anymore. So here's a fancy slide that shows what's really going on, right? So you have this thing called T helper cells. And now this is the most gory of the details I'm going to give you. But you have these things called T helper cells, which at birth they don't do anything yet. They need to be programmed. They need to be taught. They need to learn what's going on in the world. So as soon as you get exposed to something, they differentiate into the type of cell that would react to that. So if it's a parasite, they go down the road of Th2. If it's a virus, they go down the road of Th1. If it's an intracellular bacteria, they go down the road of Th17. Don't worry about the names. It's just a symphony, right? And the guy who's recognizing and keeping this symphony in place is sitting there trying to tell everybody what to do. And they send out signals all the time. You're going here, you do this, you stop here. That's in a perfect world. What do you need to make that work right? Well, you need vitamin D. You need vitamin A. You need good, healthy gut bugs. You need lack of exposure to bad things in a high enough volume that it's toxic. And then all of a sudden you start to develop tolerance. So what are we doing wrong? Right? Tolerance promoting, vaginal delivery, breastfeeding, avoidance of antibiotics and antacids, adequate maternal vitamin D and A, adequate maternal microbiome, primarily through diet, no serious maternal infections. That then promotes a really healthy microbiome. The flip side of those obviously does the opposite. If the microbiome plus your host genetics work out good, you end up balanced and you have normal immune tolerance. You flip it to the other side and you could have dysbiosis and GALT intolerance, and next thing you know, you have disease. So we're trying to reverse this process. We're actively trying to help people understand that this is really important. So how can we go back and redial the system back to what it should be? Well, we're starting to look at, can we give moms back bacteria? Can moms start eating microbes again that would help them? They just went to the jungles of South America and found indigenous tribes that had something around 42 bacteria that we'd never seen. Didn't even know what they were. But they were normal commensal flora. They were not pathogens. They were good bugs that lived inside these indigenous folks that were promoting health properties to these people. We lost them all, primarily because of extinction, that we need to get them back. So we're going to be looking at this. So the inflammatory signal comes in, it's recognized by the cell, and then the cell goes through this process of transcribing genes to allow the response that we want to see. So now we're going to shift gears just a tiny little bit. Anyone ever understand what the word autophagy is? Okay? Autophagy or autophagy is basically a word that we use to discuss how we get rid of dysfunctional cells. And I'm going to give you an analogy. Imagine you had a train, and the train is a wood-fired train. It burns wood to get from station to station. You used to have enough wood to get to station 10, but there's 20 stations. At station 10, you're stuck. You need wood. What would you do? Well, you'd look around for wood. Where would you find wood? Well, on the train, you'd look at the benches. And you say, oh, the benches are made of wood, so maybe I'll start breaking down the benches. Which benches would you break down first? The broken ones, the older ones. So you start breaking down the older ones until you got enough wood to get to station 20. What happens at station 20? You go back and rebuild everything, right? You go buy fresh wood and you rebuild the system. This is the analogy for what the human body does. The interesting part is, what's the major inducer for autophagy? Well, it turns out the number one thing that turns off autophagy is eating. When you eat a lot, you're anabolic, you're building, right? So you think about a weightlifter. What do they do while they're weightlifting all the time? They're chugging shakes. They're eating branched chain amino acids. They're trying to build the system. If you don't starve, you don't turn on the system, right? Fasting, exercise, and sleep are the three most important things to turn on this mechanism of clearance, right? So if you think of what's the number one thing autophagy would be useful for? Clearing dysfunctional cells. What kind of dysfunctional cells does the human body have? It's cancer, autoimmune cells, inflammatory cells, right? So now we're going to talk a little bit about food, right? What does food have to do with this? Here's what looks like when you have autophagy competent. You have these normal cells that are doing their job, but on the autophagy deficient side, when you eat all the time, look at this. Increased bacterial crossing over into the gut lining where it shouldn't be. Increased inflammation, decreased immune cells that do their job, simply by eating all the time. Cell Magazine, or Cell Journal, linking the human gut microbiome to inflammatory cytokine production capacity. Now we know that these gut bugs directly tell our body how many of these inflammatory cells to make. Take a step back on that one. Our gut bacteria directly talk to our immune system and tell our immune system how many inflammatory cells to turn on. There's another landmark understanding. So if your gut dysbiosis is occurring, you have bacteria that are not working. Not only are you leaking potential proteins through, causing food reactions, food intolerances, food peanut allergies, dysfunction of how those microbes work, but now all of a sudden it's teaching us that now inflammation can happen just by the bacteria. So here's a study looking at what happens with the microbiome. If you have genetic richness, and I think of, from an environmental perspective, think of the rainforest. The rainforest has a plethora of species, and those species work together symbiotically to keep the rainforest in a good position. As soon as you start wiping out species, the rainforest becomes sick, and it doesn't work as well. You're seeing this with coral reefs, you're seeing this with other things. Well, the human body is no different. Your intestines are a garden of bacteria, and those bacteria are specifically set to do a job for us. If we start to perturb them, they all of a sudden stop working. So here, high microbial complexity, a euphemism for a very diverse rainforest. Low risk of metabolic diseases. Switch the side, obese, microbial complexity low, which goes along with obesity. They go hand in hand. All of a sudden, you have high metabolic disease risk. So we're now learning that the microbiome has complete effects on how we gain weight. This is madness. Bacteria teaching our body how to gain weight. Well, we know that exists in pregnant women. We already proved that. But we now know this exists in humans in other ways. Interesting thing is, dietary response to intervention is high. Well, that makes complete sense. If you're in great shape, the diet wouldn't make any difference. Unless you give the bad diet, then you can perturb it this way. But if you eat a really healthy diet, you can actually shift that balance that way. Studied and proven. This is what it looks like. There's your stomach, very few bugs. It shows none, but there's actually a few in there. And then all of a sudden your small intestine starts to increase in size with numbers of bacteria. And all of a sudden you get down here colon, that's where most of them are. They're talking to us. It's hard to wrap your brain around that. But these microbes literally talk to us. Then they went and said, okay, well, what else helps it do its job? And they said, well, dietary fiber, and then the production of these things called short-chain fatty acids, enhance oral tolerance and protect against food allergy through diverse cellular pathways. That's a fancy way of saying when you eat fiber, your body releases chemicals that help teach the gut how to remain tolerant. Now, anytime you read anything from Cell, Nature, or Scientific American, it is top shelf. If you get an article that's up there that's from Cell, you know it's been vetted, it's perfect, it's beautiful. This is unbelievable stuff. And it turns out, what do you need for this? Vitamin A, vitamin D, and good gut bugs. They help get the immune system to do what it does. Those military police come in, control the inflammation, everything gets beautiful again. What are people not getting? Well, we showed vitamin D, smog can do something with that. What else do people do all day long? They sit indoors, not vitamin D. If you don't eat a really healthy diet with lots of beta carotene, lots of orange, red, yellow vegetables, you're not getting enough potential vitamin A. You're setting yourself up for immune system tolerance dysfunction. Bottom line, no matter how you slice it, it's the environment. It is either the chemicals that we're exposed to, the food that we're not getting in our system, the bugs that are not being treated the right way, or something else in our environment is triggering an intolerant system to occur. So if you look at this from a perspective of what does it all look like? Right in the center is that big eye, right? What's driving inflammation? Because inflammation then drives this dysfunction of the proteins that our immune system overreacts to. Well, dysglycemia. Anyone know what that means? It means dysfunctional sugar. Right? How do you get dysfunctional sugar? You consume too much of it, you end up with diabetes. But you don't have to have diabetes to have dysfunctional sugar. Everybody who consumes high volumes of sugar has a spike in their bloodstream before insulin can catch up and bring it down. Anytime you spike your blood sugar, you are at risk for glycation reactions. Glycation reactions are taking proteins and cross-linking them with sugar. They are pro-inflammatory at every level. You have hormones. Women have an amazing, amazing human body. Way more fascinating than men. Men are very boring scientifically compared to women. The estrogen that women have, there's a receptor almost on every cell in the entire body. That estrogen provides unbelievable benefits, but it's actually now turning out to be very dysfunctional because we have a lot of estrogen in this society that are foreign. They're not ours. Linings of cans, credit card receipts. These are foreign estrogens that our body has to somehow deal with. Oh, by the way, if you unfortunately have a CYP1B1 gene, you can't break down the estrogen into the right type, so it becomes an estroquinone. That estroquinone is toxic. It damages DNA. It's a precursor to autoimmune disease and cancer. Don't know your genes, but if we knew your genes, we could give you an idea. Bottom line is, do you need to know your genes? No. You need to assume you have dysfunctional genes, and then find out later if they were good. Insomnia. All the TV shows show, what does the CIA do to somebody when they break them? Make them sleep deprived. Because sleep deprivation will really destroy the mind. It is unbelievably stressful, inflammatory, detox defects. If your genes are broken, you can't detoxify, you're in trouble at lower doses, right? Vascular oxygen defects. I'm going to show you a slide that shows how hypoxia directly causes immune system dysfunction. Infections, environmental reactions, excessive exercise. Ultramarathoners are at high risk for ALS and other autoimmune diseases. Why? Because they tend to run a lot. They tend to produce a lot of reactive oxygen species from all the running, breathing, everything they're doing. And if they're not consuming lots of vegetables and fruits to sop those things up, they're at high risk. Food reactions, GI dysfunction, stress chemistry, and then you have your big friend there, autoimmunity. So I want to talk about what I think is now becoming the biggest player. When I started in medicine years ago, I was mostly a pharmacologic guy. I came out of Emory and UVA, and I was medicine, medicine, medicine. I was taught at the Meccas, this is how we do things. And then I met my wife, who some of you may know. And she smacked me upside the head. I still didn't listen. She smacked me upside the head. I still didn't listen. She smacked me 5 more times. I finally started going, okay, something's wrong here. And then she finally convinced me that I was really wrong. And then Kathy Russo said, you know what, let's go see Dr. Weil. And I said, who's Dr. Weil? And then my wife's like, oh, I've been following him for years. So I flew out to Arizona and started learning from this guy. Blinders off. No longer am I the horse that looks like this. All of a sudden, it's very clear that pharmacotherapy is a Band-Aid. It is no longer the reality that we all should be talking about. What we really should be talking about, what is the root? Where is it starting? I don't want to treat the leaves. I want to go down to the base in the dirt and find out where that thing is broken so we can start again and rebuild that tree. This is probably player number 1. Mental stress is unbelievable for humans right now. We live in a world where we are over-inundated with things that turn on our sympathetic system. Whether it's the cell phone, the obligatory email, the bings, the buzzes, all these things, it's messing us up. Kuntz has been beating me up for years that stress is number 1 and nutrition is number 2. And I've been saying nutrition is number 1, stress is number 2. I think he's right. I don't like to admit it, but I think I have to. So here we go, neural circuitry immunity. Does your brain have anything to do with your immune system? Well, we know, we talked about earlier, if you get depressed from a divorce, your immune system gets shot. Depressed people have 10x more disease than non-depressed people. Why? Because your immune system is in complete connection via the vagus nerve with your gut. Everyone have a gut feeling? Your gut has an entire brain. It's called the enteroendocrine system. It has a whole brain in there that helps convert signals back and forth to help us understand things. If this isn't working right, guess what happens? If I put a bull in front of you and he starts, what are you going to do? You're going to run. So what does your body do in order to run? It shunts all of the blood you have in your body to your brain and your muscles. Everything else gets shut off. So guess what you don't want to do if you're stressed? Eat. The sympathetic system shuts off gut peristalsis. It shuts off acid production. It shuts off everything you want to help digest. So when you're pissed off and you just had a fight and you go chug a 30-ounce Coke and eat a big pizza, you're just stressing the system unbelievably on top of the immune stress you just did neurologically. Okay? Neuromodulation, immune system, intestinal immune system, and relevance to inflammatory bowel disease. This is clear. I have tons of Crohn's and IBD patients. These kids do phenomenally on diets and everything until they get stressed. I have a cautionary tale. Integrative medicine is only as good as the patient's compliance. I can take you and help you put your disease generally in remission if I can figure out what's going wrong. I had a little 7-year-old girl, came from Germany, and this was actually one of the really sad stories. Parents didn't want to do traditional medicine. In Germany, they have a lot more of the other side, right? What they call Eastern philosophy. So they came, they went to Wake Forest, they didn't like what they heard, so they came, found me, and they said, oh, we'd like to do this. So we started researching what's going on with this. Now, for those who don't know it, Crohn's disease in a young child at that age is very aggressive. It's not a very benign disease. The younger you are when it turns on usually means you have very dysfunctional genes, which means it can be very inflammatory. It's going to be a player. I knew this going in, but I tend to be pretty aggressive. I'll go at things anyway. So we had this girl in great shape. She was on a couple amino acid shakes. She was on a gluten-free, dairy-free diet. She was taking some supplements to heal herself, and she was in complete remission. Parents have an oops baby. Oh, by the way, they got pregnant. They didn't expect it. And unknown to us, during this period of time, this young girl was very frustrated that she's no longer the apple of mom and dad's eye. So she decides to stop taking the shakes, hiding them behind her bed. She starts sneaking out with her friends at school, eating whatever, and her Crohn's explodes. 3 surgeries later, she lost half her colon, and she's now on full medicine. So this is where it's scary, right? So if mental stress comes to bear, it can override anything we talk about. And everybody needs to understand this, because we're going to talk a little bit about how to help that later. Here's a lovely cell, right? Here's your vagus nerve, has these little fibers coming in. There's an enteric fibrous, a little neuron in the gut, and it sends a little acetylcholine, right? It goes over there and it says, hey, cell, release Tregs, which is a downregulatory signal for the immune system. That's the military police. Or release TNF-alpha. TNF-alpha is an inflammatory signal, right? So if you're stressed, TNF-alpha turns on. If you're relaxed, Tregs turn on. Direct effect on the immune system. Acute mental stress increases cortisol right away. You're running from that bull. You're getting out of here. You're gone. Cortisol turns on. Cortisol goes in that little receptor right there. It sends a signal down. It says, okay, NF-kappa B, do not turn on. We don't need you right now. We do not need inflammation. We need to run, get the heck out of Dodge. We're good. Okay, you're gone. Now you're done. You've beaten the bull. You're away. Now that system can turn back on if there's inflammation. If you tripped, fell, did anything wrong, it can turn it back on. Anyone ever heard of insulin-resistant diabetes? Right? What does that come from? It comes from inflammation of the receptor. The receptor stops working well. You release the insulin, but it doesn't jigger the response, and you cannot use the glucose. So you end up with diabetes. Under chronic stress, the same things happen. If you are chronically stressed over and over and over again, this receptor here no longer receives a signal from cortisol. Now, NF-kappa B gets turned on, unrelentlessly. So NF-kappa B, nuclear factor kappa B, goes inside the cell, right into the nucleus, and now kicks out all these pro-inflammatory cytokines, tells your immune system, we've got a problem, go kill it. What happened if that problem is you? helping that problem is anti-citrullonated cyclical protein in your knee joint. Mental stress that's chronic is crushing you. We never knew all this stuff. Now we're getting it. The immune system's heavily involved. And we can go through, in an hour, I was talking to Chuck earlier, I hemmed and hawed for 3 months on how to do this talk because there's so much data that I could give you, but is the data really that relevant? Or is it really just the story? So I'm trying to give you a story instead of the data. I can give you data all day long, we can get crazy, but that's really sort of useless in the long run. So what do we need to do? I can show you more pathways, but it's not relevant. But what we do know is that meditation and prayer increases the parasympathetic system. Parasympathetic system is the opposite of the sympathetic. If you're chasing by the bull, you've got the sympathetic turned on. So you want to go into parasympathetic mode. You want to go into relaxation mode. How do we get to relaxation mode? Well, you got to get the bull to go away. Well, what's the bull? Well, if you're divorced, it could be your wife or husband. If it's a disease or whatever it is. What is the bottom line in life? Too many people are trying to control their narrative. You cannot control your narrative. You can only control what's in front of you. I have kids come in all day long stressed out about Facebook. Really? In the grand scheme of things, does that matter? I think in America we should have obligatory one-year mission work or military. All these young kids need to see what the world has to offer on all levels. Get out of your little microcosmic world of your world sucks because somebody told you you're a jerk. Who cares? I tell the patients coming all the time, they come in stressed, I tell this girl, does it really matter that she called you this name? Well, no, not really. So why are you stressed? Well, it hurt me. Why? Well, it did. You're letting it. That's the bully. You're giving the bully all the proof. As soon as you say to the bully, I'm done with you, what does the bully do? Goes on to another player. Moves on. We can all control our stress level if we allow it. Problem is we're not allowing it. So what else, right? So here it is. When you meditate and pray, this has already been proven, anti-inflammatory immune shifts, increased GI motility, stops moving through, increased gastric acid production, increased mucus production, and decreased intestinal permeability. Beautiful. So what do we all need to do? Meditate, pray, relax, hang out with friends, have a glass of wine, take it easy. All right, final, food. This is near and dear to my heart. All right, another one of my crazy board pictures. If anyone wants to come to my office, you're welcome to see my whiteboard. It sits right behind my desk. There's your good friend sugar. Right? Sugar goes over and says, hey, Mr. adenosine monophosphate kinase, that's an enzyme. Hey, buddy, turn off. Well, adenosine monophosphate kinase helps you make ATP. Anyone ever heard of ATP? Adenosine triphosphate? That's what you use in all of your energy. That's how your muscles move. Right? So when you consume a lot of glucose, why do you feel so sluggish? Well, you're turning off your production of ATP. Oh, but by the way, you turn on something called hypoxia-induced factor 1 alpha. Hypoxia does that, and so does excessive sugar. Well, what does hypoxia-induced factor 1 alpha do? It turns on vascular endothelial growth factor. What does that do? It turns on myeloid-derived suppressor cells. That then says to the natural killer cells and the Th1 cells, shut up, sit down. They kill cancer, they kill pathogens. So you're telling them to shut off by eating sugar. Really? Then there goes by and says, hey, Mr. Infection, proliferate. That infection then causes inflammation, right? Tissue damage. Here we go back to tissue damage. Here's another route for autoimmunity. We talked about toxins, we talked about other ones. Here's another one. If I give you tissue damage from an infection, I can now all of a sudden present tissue that is no longer yours. It has been altered and now it can become autoimmune. So now we have another way to develop autoimmunity. Glucose. Anyone ever heard of the word obesity? It's a joke, right? Obesity is the number one risk factor for cancer. Number one risk factor for autoimmunity. Why? There's one reason. It's one reason. There's many others, right? Here's another piece of the pie. AMP kinase, when it goes down, turns on STAT3. It's a gene. That turns on IL-17. That's a protein that turns on Th17. That's the major player in autoimmune disease. If you upregulate Th17, you're upregulating the path to autoimmune disease. And then go back to the beginning, glucose. Pro-inflammatory cytokines begin within an hour of a meal and don't resolve for 3 to 4 hours. If I give you a piece of Wagyu beef, corn-fed beef, 3 ounces, and I draw your blood after you eat it, or I give you a piece of grass-fed beef. Cows have 4 stomachs. Why? Because they eat grass. They don't eat corn. We feed them corn. Same thing we do to ducks to make foie gras, because it's fatty. right? That meat's beautiful, it's fatty, we love it, we eat it, right? But it's pro-inflammatory. When they checked the blood of those two people afterwards, the one who ate the wild game cow had no issues. The one who ate the the corn-fed, tons of issues. So now we have a problem of what does food do, right? Here's an increase in that NF-kappa B, right? They looked at this in a mixed meal, and they found that when you eat certain types of foods, pro-inflammatory foods, you turn on the gene for inflammation. So, interestingly enough, look at the date on this. It was the first time I talked here. This was 2009. It was a lecture I gave here in 2009. I think this is the first time I talked. I probably have to look back. I wrote this up during that time. This was right after I finished the Arizona Fellowship. And fascinatingly enough, mind, body, abnormal nutrition, and chemical exposure are all there. There's others, but they are the three major players. And if they come to do their job, by we fix them, they can reduce disease and give us back health. Three major pathways that we can control. Right? Because a lot of these other things you can't control. You can't control the genes mom and dad gave you. Right? Not yet. CRISPR, maybe. But not yet. But you can control how relaxed you let yourself be. You notice how I said you let yourself be? Because you're choosing to be relaxed or stressed. Nobody can make you stressed ever if you choose not to be stressed. Nelson Mandela sat in a prison for 27 years. Came out and became the president of a country. How did he do that? Because he chose to wait. If he can do it, why can't we? He's not special. He's a human. Abnormal nutrition. Does everyone in this room have the choice ability? They do. You can choose to eat healthy. At my office, I've tried everything you can imagine to get my staff, or our staff, to eat very healthy. Failed miserably. And my wife and I talk about this. She wrote a book on how to help people heal. We failed miserably. The problem is, unless you want to change, you will not change. I can give you all the water to drink. You have to come up and drink it. Chemical exposure. You can avoid as much as you can. Learn. This is the Environmental Science Center. Learn from these guys how to avoid all the chemicals that bug you. The Environmental Working Group is a huge partner with this group. They have tons of website information. Learn. It's not rocket science. None of this is very difficult. All the stuff I showed you, the gory details, that's difficult. But the real answer, not difficult. Randy Girdle came here and did an amazing lecture. He's won a bunch of awards. Anyone who hasn't read anything about the agouti mouse, I highly recommend you learn about the agouti mouse. Because that's the epigenetics. That's what you can do to prevent your genes from turning on the wrong way. And it's all the same. Eat well, relax, sleep, avoid chemicals, exercise, move, blue zones. It's really simple. None of this stuff is rocket science. If anyone's interested, if you like this stuff, you're welcome. It's free. You can go on our website. We have 2.5 years of articles archived. They drop off every week as new ones get added, or you can get the newsletter yourself. It's all up to you guys. But this is the reality of how we can prevent autoimmune disease. And I hope and I pray that I did a reasonable job helping us all understand what the genesis of autoimmune disease is, because if we all hear the story, we have an opportunity then to change the narrative of our own lives and therefore have a chance to live long, prosperous, healthy, and have a compressed mortality and just drop dead someday. Beautiful. That's it.
We have time for a few questions, but if you would, when you ask, I'm going to need to hand you a mic so everybody can hear it. So anybody have a question? Over here.
Dr. Magryta, you talked a lot about smoking. I was wondering about vaping, how that's different or the same.
So the question is, we talked a lot about smoking. What about vaping? So vaping, the genesis of the whole vaping fad was to find a way to wean humans off of cigarettes, believing that cigarettes are way more noxious than vaping. So they developed a way to take nicotine and rapidly aerosolize it so that you can inhale it and get it the same way you would from a cigarette and get the same effects of the nicotine without the toxins. The problem is that there still are toxins in the vaping material. And so there still will be inflammatory responses, but it looks like it is less than cigarettes. The problem that we're seeing now with all the deaths is related to contaminated vaping devices, where somebody put vitamin E oil in there and thinking vitamin E oil would be not a big deal. Well, vitamin E oil is great for you in your gut, not great for you in your lungs. When you aerosolize an oil, it'll go into a mist and you'll inhale it, and then when it gets in your lung, it reconstitutes into an oil. And I don't know if you've ever seen an oil droplet sit on something, right? The immune system doesn't like oil in the lungs. It's an automatic problem. It's like silica. You inhale silica, your immune system is going to see it and go, you should not be here. So it's going to kill it. Well, if you inhale enough of it, what's going to happen? You're going to get inflammation until you die. And that's what's happening. People are developing acute respiratory distress syndrome. Their lungs are filling up with fluid and they're dying. Vaping in and of itself, it's only a matter of time until we see all the data showing us that it's causing disease as well, autoimmune and all of it. I'm convinced it will do the same. It's just, again, anything new is not a problem until we prove it, right? And this is a problem with America. Precautionary principle exists in Europe. They got to prove it's safe before they can release it. We are the dummies that have to prove it's bad for us after we get sick. So that's about the sum total of my knowledge on vaping.
Could you elaborate a little bit on fasting? You mentioned that as a positive way to eat.
I know a lot about this. So this is a hobby of mine, fasting. So there's a lot of data pouring out on fasting. It turns out humans have fasted forever, and we all know this from religious experiences. When you fast for a prolonged period of time, you get heightened awareness. And it's actually very true. I believed forever that I was a hangry human. If I didn't eat 3 to 4 times a day, I was angry, frustrated. My wife would say, well, we got to feed you, we got to feed you, we got to feed you. And it turned out I started reading the science of fasting. And oh, by the way, I'm not hangry. So it's, yet again, showing what our mind does to us. So when you fast, you go through a period of time where you do not give the body any sustenance of any kind. That tells the body, okay, I need to go into a storage mode, right? I need to go into a defense and repair mode because I don't know where my next meal is coming. Now remember, genes in the human body are in place for 2 reasons, right? Procreation and survival. That's it. That's all they exist for. So if a gene is in the body, it wants you to survive and it wants you to make more of yourself. So when you wrap your brain around a gene, that's it. So when autophagy genes or genes related to fasting turn on, they are saying, okay, I don't know when the next meal is coming, so let's break down the bad chairs on the train. So you're starving, let's start breaking down cells because we need raw materials to build more. So let's tear down that old building, let's tear down that old thing, let's do this, and give me all those amino acids, all those fatty acids, all those glucose molecules back, and let's start fresh. So your body starts to eat itself, autophagy. And then it says, okay, when you feed me again, I'm going to now use that to store it for the next time you stop feeding me. So when you fast, you actually allow yourself to become catabolic, which means breaking down. Anabolic, you know from steroids. Anabolic means building up. There's a chemical in the body called mTOR, mammalian target of rapamycin. Mammalian target of rapamycin is the master switch on-off for anabolism, catabolism. If you eat, mTOR turns off and you become anabolic. If you fast, reverse. mTOR turns on and you become anabolic. When you fast, mTOR turns off and you become catabolic. So by the process of fasting, you are repairing your system. And again, like I said earlier, what are the dysfunctional cells you go after first? Anything that your body recognizes as weak, stupid, or bad, cancer cells, dysfunctional cells, it's going to go after them and break them down first to heal you. But interestingly enough, when I went back to that other slide where it showed glucose, it shuts down the NK cells, natural killer cells. That's part of our innate immune system that's there as a surveillance mechanism to go after cancer cells. So when you starve, glucose goes down, and then that AMP kinase goes up, VEGF goes down, hypoxia-induced factor 1 alpha goes down, MDSC goes down, all these names, acronyms that I know backwards and forwards, but it all goes down. Next thing you know, Th1 and NK cells turn on. And they go now and start killing everybody that's bad. It's a beautiful thing. They release all those raw materials back into the system to now do its job. So now we go into okay, that's the science. So what does the data tell us about how to fast, right? So I have now been for 3.5 years fasting for about 16 hours a day. And usually 1 day a week, I only eat 1 meal a day. And again, you'd think I would be angry, mad, I feel phenomenal. Most days. I eat usually, like today is a day I'm eating 1 meal. I ate at 1 o'clock today. I'm not going to eat dinner. I did this talk. I don't like to eat before a talk because then it gets all my sympathetic system working. So I'm going to gut food and and then I'm not going to eat late because I have this little ring on my finger now that tells me how I sleep at night. And if I eat within 3 hours of falling asleep, my sleep numbers go. And if you want to get into the data on sleep, I'll teach you some of that. But so that's called time-restricted feeding. True fasting is where you drink just water or black coffee or black tea or something without any caloric density for more than 24 hours, preferably 48. That turns on a whole other cassette of genes that are beneficial. Okay? I submit to most people that if you can get away with eating breakfast and lunch and nothing else, that is the perfect way to do it. The problem with that is what? Socially, it's very dysfunctional. What's the most important meal of the day for social output? Dinner. So that's why I've chosen to skip breakfast, eat late lunch, early dinner, and then on the weekend, if it's a Friday night and I'm out with my wife and other people, I'm like, out the window, here's my cheat day, and I'll just do whatever. Okay? But the science is critical. Fasting is fantastic for you, and I submit if you do not have a problem with low blood sugars, I highly encourage people to fast. Now, if you are over the age of 60, if you have any cardiac disease, anything that's potentially where you are not a normal norm, talk to your doctor first because these things are not without risk, right? Just like saunas. Saunas are fantastic for you, but you could have bad things happening in a sauna if you have heart disease or you drink too much or something like that. So, long-winded answer to a short question.
Yeah, this is a question here, and then we'll get
Thank you for the very comprehensive and enlightening lecture. I'm trying to make it practical for me. The difference between good biota and bad biota and how do you change it? I mean, I assume everybody's got the American diet. That is difficult to change. So how do you change your biota?
Everyone heard the question? So the gut microbiome happens to be probably my favorite topic. And I've read as much as there is humanly possible to read about this topic. And the fascinating part about it is we are barely understanding it. I used to think probiotics were a really good answer to help us with this, and it's turning out that's not really the case. Probiotics are useful, but in only certain populations. The microbiota of the gut is only really changeable by 2 methods right now. Well, one is called fecal transplant, where I take stool from a healthy donor, microfilter it, put it into an enema, and up your bottom, and recolonize your intestines with somebody else's good flora. That is now being done for diseases like C. diff colitis and Crohn's and others. Now, there is a problem with this. You can actually induce autoimmune disease in somebody by giving them a fecal transplant. And this has been shown where folks got a treatment for C. diff colitis and within a week of that ended up with RA or lupus. Because when you give somebody else's microbes to you, they're all metabolically active. And if you, oh, by the way, have a gene that says you have an HLA DQ2, DQ8, you might turn on celiac disease, right? If you have a NOD2 gene defect, you might end up with Crohn's. So not knowing your genetics, this is not a simple game yet. But that is coming. Time will iterate this. And what's going to end up happening is we're going to develop microbes that we know are good for us from those jungles of South America or Africa or wherever where these pathogens haven't been taken away. We're going to produce capsules, and you're going to swallow them to recolonize your gut. That's step number one. Not there yet. So what can you do? The only option you really have, avoid things that kill your gut. Okay, so what kills your gut? Antibiotics, antacids, certain foods, right? Predominantly refined carbohydrates, bad fats, right? Those are all toxic to your garden. So if you avoid those things, and there's others, but if you avoid those things, now you give a chance for your flora that you have, assuming you haven't made your flora extinct. Now we do this, we test our kids. So I send off a stool kit to a lab in Asheville, and they give me back a printout of RNA microbes. So they look at actually the RNA of the bacteria, and they tell me what gut bugs these kids have. And based on that, I can look at a profile and say, okay, this kid's garden sucks. And frankly, this is actually more the norm than not, because I test sick kids, and their gardens are terrible at 5 years old, at 6 years old, at 7. So the only iteration you have, and if you remember that slide I showed earlier with microbial richness, food sensitivity, the American diet is the killer of the microbiome. The anti-inflammatory or Mediterranean diet is the only way to fix it. Now, does it happen overnight? The answer is no. You can destroy your gut biome very quickly, just like I can blow up the World Trade Center in a minute. How long does it take to rebuild? A couple years, right? The gut biome is not much different. You can do a lot of damage very quickly, but it takes a much longer time to rebuild it. So it's a process. It is really, truly eating lots and lots and lots of fiber, right? Americans eat about 15 grams of fiber a day. Historical intake of fiber was anywhere from 85 to 125. We're nowhere near the fiber dose. Now remember, on that earlier slide I showed that fiber feeds the bacteria. They consume that fiber, and then they produce chemicals that our enterocytes or our gut cells use to stay alive. Symbiosis. If you feed fiber, the gut bugs use it, and then we end up good. When I eat asparagus now, I don't cut off the hard end anymore. I eat the hard end. Sometimes it comes out, sometimes it doesn't. When it doesn't, I'm like, microbiome happy, right? So anything that's fibrous is very good for you. So food-wise, vegetables, fruits, beans. Legumes have the most fiber of any plant food, 9 grams per cup. Berries have 3 grams per cup, and then it's sort of down from there. So from a dietary perspective, you really, really, really want to focus on fiber primarily, and you want to focus on avoiding those things that will kill your gut bugs. And again, we don't know what the whole story of pesticides are yet. What is glyphosate doing to your garden? There's some preliminary data that glyphosate is ruining your garden. Oh, sorry, Roundup. Yeah. Roundup is ruining our garden. Right? So every food you consume that's non-organic could potentially be doing damage to your gut bugs. And remember, it's only going to kill the weak guys, right? And the weak guys, a lot of those weak guys are just peripheral players that hang out and do small things, but they're very important things. The big guys who survive do things too, but some of them do bad things if they're too big. E. coli is one of those classic stories. We need E. coli. Within 6 months of being born, you have tons of E. coli in your gut naturally. The problem is if you produce too much E. coli, they then release a chemical in the system called LPS. We have antibodies against LPS. LPS then induces systemic toxemia. This is one of the reasons people drop dead after eating a big steak. Does that answer the question?
Mine was just a follow-up question to fasting. Would you recommend the same for females as males?
So the question is, would you recommend the same fasting event for females and males? And the answer is, it depends. So I have found that the majority of the women that I talk to can fast time-restricted feeding very well, with no problem. Skipping 1 meal, eating 2. Harder to do skipping 2 meals, and it also depends on age too. I always talk to parents all the time. 2-year-olds often skip meals. They constantly will eat 1 here, 2 there, none there, because they are not eating from the purposes of that we eat, right? They're eating for sustenance when their body says eat, right? And that's irrespective of woman and a man, female or male. Girls, boys, same thing. As we age, differences change. So as soon as you become pubertal, you need to maintain 14% body fat or more in order to have a period and have breast fat tissue. If you go below that, high-end athletes go below, they become amenorrheic. They no longer have a period because the body is very smart. It has genes for two reasons: survival and procreation. If you cannot procreate well because your body fat is too low, it's just shutting that off. You are not fit to produce a child. So it does, it shuts it off. So fasting by nature would depend on if you can maintain 14% body fat. And so that's what I tell folks. If you can eat enough during the meals that you choose to maintain the body fat that your body wants to survive, amen, all day long, twice on Sunday. But it is individual, and this is medicine. Everybody's different. It is completely individualized. If I tell this whole room to do the same thing, it's going to work for maybe 50%. Good?
Okay. One last question, and then we're going to... We have two
This is the rapid fire session.
This is the rapid fire.
Did you have questions?
But then we're all going to head over, including Dr. Magryta.
I'm staying.
Here we go.
I have a debate with a family member who's a food science major and now a dietitian, and her family is very pro-GMO foods. It's better for you, you know, we can feed the world and all that, and I'm rather anti-GMO foods just because I don't want to eat corn that already has pesticide in it. Where do you draw the line between what's too much there?
So I think the question is twofold, and I'll do it quickly. If your tolerant mechanisms are in place, like we went back to the beginning, if you were born as a child, you did not get antibiotic exposure, you ate well, you did all the right things, it probably will not matter that the food was genetically modified because your body will not overreact to the protein changes. Your immune system wants to react to protein because all pathogens are protein-based. Okay? So you got to keep that in mind. So when you alter a protein, genetically modifying it to make a hybridized whatever, wheat, corn, something, if you have a dysfunctional tolerance immune system, that could potentially be a neoantigen. Okay? If your immune system is unbelievably tolerant, you've done everything right, the GMO probably matters not. So the problem and the reason that we go back that first slide with the meteoric rise of these diseases is because our gardens are broken. So we have unregulated experiments happening within the last 30 years that the previous 3,000 didn't exist. So GMO is a problem if you have a tolerance problem. So I guess that's the simple answer. So I would agree with that person if they understand immunology. The likelihood is they don't, so then it would be a more interesting argument.
Oh, excuse me. I watched the documentary that you recommended.
Oh, isn't it awesome?
And yeah, my dad actually worked for DuPont for a short time, just a few years. But my question was, are there any updates on the Gen X chemical in the Cape Fear River?
I am not up on that. John, do you know that? I know that the issue's happening all over again. The chemical that they're producing now on the spin-off company called Chemours is similar to the original chemical, which was the Teflon, the PFO, and they just changed it by one carbon atom. It is being released as the same issue in the Ohio River now is being released into the Cape Fear River, and so now I know there's more litigation and stuff starting, but I don't know any more data on autoimmune risk and things, but that's, again, this is the next piece of stuff to watch. Like there's a hotbed of thyroid cancer in North Lake Norman over by the Marshall Steam Station, coal plant, right? And now they found coal ash ponds over there too. So if you think about an autoimmune disease risk, the thyroid is the number one disease-centric autoimmune problem. Thyroid goes before anything else in the human body. It's a very sensitive organ. So when you start seeing thyroid cancer clusters, you know something toxicity-wise is occurring. And the really scary thing is happening in young girls and younger women. So they are more at risk for this for some reason genetically. And so, when it comes to toxins, I come back to the simple premise, we don't want any. Do everything you can to avoid it. I have a whole house, all of our water comes through a filter in our house, so we make sure all of our water, we live on Lake Davidson, I live over in Davidson, and our water is theoretically connected to Lake Norman. So we could be potentially getting water that is contaminated. We've checked it recently. We have a tiny little bit of hexachromium, which I was not happy about, which I don't know if you watched Aaron Brockovich, but that was the chemical from Aaron Brockovich, but it's a tiny amount, not really known to be associated with damage, although we know what that means. So we filter everything in our house, but I don't know the answer to that.
Do you know he's coming in October?
Yeah, down south, yeah. A good friend of mine, Russ Greenfield, was the first fellow with Dr. Weil. Russ is now running the Integrative Medicine Nutrition Cancer Center at Novant Health, so he's an awesome guy, and he's bringing Dr. Weil in.
Okay, thank you very much, and we'll head over now to the conference room where we'll have some snacks. Thank you, Dr. Magryta.